Hello everyone, and welcome to Control Automation Day 2024. We are proud to deliver this keynote presentation from Universal Robots, sponsored by Mouser Electronics. As robots continue to be implemented in more and more facilities around the world, many situations have been tried and true as the ideal projects for automation, like picking up boxes or sorting parts on a conveyor belt. But the past few years have seen incredible leaps in computing technology, and along with those advances, more innovative solutions which were once very difficult or even impossible to handle for robots. Today, I'm excited to learn about how modern technology is handling the approach to designing the solutions for these complex but very intriguing automation challenges. I'm joined by Mike DeGrace, the manager of Universal Robots' UR+ ecosystem, the family of integrators and engineering partners working together to investigate and tackle tomorrow's robotic solutions. All right. Well, Mike, thank you so much for joining us today. I'm really excited to have your experience and your knowledge with UR and with the UR+ ecosystem here to share some of your experience with our audience today.
Yeah, I'm excited to be here. Thank you guys for having me.
So before we get started, I always like to learn just a little bit about the person that I'm talking to, a little bit about your background and your history. And so I'm interested, what got you into this field of robotics and automation and your interest in, particularly in the industrial applications, kind of both covering your educational background and the things that happened outside of school that led you to where you're at today?
Yeah, so actually by my, if you just looked at my degree on paper, I don't know if I should be in robotics. I always loved math and science when I was a kid, when I was growing up. I knew I was going to be an engineer. I liked to know how things work. I always enjoyed taking things apart and wanting to understand how they work together. And so I knew I'd like the field of engineering, but I actually went to school for chemical and biological engineering. There's a really small college in the foothills of the mountains of Colorado, Colorado School of Mines in Golden. And it's famous for mining engineering and for petroleum engineering and really the oil industry. My grandfather attended the university for chemical engineering, and he went on to work in refining. And so that's largely what I thought I would do. I really, really loved chemistry. And so, yeah, went to school for that, got out, and worked for Frito-Lay, actually, as a process engineer. So there's a small plant in Denver, Colorado that I worked at. As part of the needs of the business there, they moved me from the manufacturing portion of the business into the warehousing portion. And that's really where I got first introduced to automation, industrial automation. So robotics, PLCs, the components, conveyor, all of that. It was a little bit of into the frying pan, like, drinking from a fire hose and learning a whole new thing. But at the end of the day, engineering really is problem solving. It's just techniques and problem solving. And so I felt like, even though it wasn't in my major, it wasn't exactly what I studied, like I could get my head wrapped around this new skill. And so, in particular, I got to work with large 6-axis robots that were doing palletizing and case packing. Became really familiar with some of the logistics needs of a warehouse. We had a really unique setup in the Denver site. And that's what got me into automation. That's really what was the first spark into automation. And from there, I worked for Festo, who's a German company. They specialize in all different kinds of components, but in particular, I worked with primarily pneumatic devices and some electric automation, ball screw actuators, belt drives, motors, that kind of thing. And then I came to Universal Robots, and I've been here now for 6, going on 7 years with UR.
I think one of the things that I've always loved the most about hearing people's stories about automation and robotics is that there's just so many applications, whether it's a Frito-Lay factory or oil refineries, just it uses technology. And sometimes it's the same technology that the rest of us deal with on a day-to-day basis, but the applications are just so diverse. But it's nice to be able to see how no matter somebody's background, that they can still change, evolve, and move, while still kind of maintaining that deep down desire to solve problems and approach things with creativity and design, which is really a large part of what we're going to be talking about today.
Yeah, couldn't agree more.
Now, I know that kind of before we get started on some of the specifics, I know that your role has changed quite a bit since you first got started in technology versus what you do now in your position with Universal Robots. But I'm just curious because we have a lot of people listening to this who are either students or just beginning their careers. What kind of advice would you give to somebody who is looking forward to 10, 20, 30 years or an entire career in this industry and would like to see themselves in a position of being able to work with fun technology and continue growing the whole time that they're in those positions?
Um, that is a really good question. I think if I look at my own experience, I'm still leaning on this in my own career, I would be to remain curious about everything. I think one of the things that's helped me, what continues to drive me, is wanting to know how things work. And that can be a piece of technology. That can be how technology works with other tech. That can be in a career. How does an organization work? How do organizations work together? Uh, I think finding ways to be curious is such a useful skill. And for some people, I feel like it comes really naturally, and others have to work at it. But the commonality is that curious people, they tend to go to really, really interesting places in their career and get to do interesting things because they're interested. Uh, Curiosity, I would say, has been the thing that's helped me the most.
When you mention curiosity, I often think about like my own kids always asking why and always wanting to understand exactly how everything works and why does this do what it does. And it seems like engineers kind of continue that mindset, and it's just that the questions we ask become more involved and more in depth, and usually relate to more expensive technology that we're curious about.
Yes. Yeah.
So, how does engineering, and I guess maybe I would kind of call the engineering the art of problem solving. I suppose it's a set of skills, but to me, it's always, since it involves that creativity, it really almost kind of goes into the field of art. But how does that tie into your role specifically as the manager of this ecosystem, the UR Plus ecosystem that deals with not just the robots themselves, but also the hundreds, thousands probably of applications that robots find themselves being installed in on a day-to-day basis?
Yeah. Um, you you worded that perfectly. I think it absolutely is an art form, uh, and I say that with confidence because there are hundreds of partners in the UR Plus ecosystem that look at very similar applications very differently, and there's no one way fits all. There's no one way totally is the way. Um, I think about like welding, and there's so many different ways that our partners approach the welding application. The commonality there being we're going to join two things with metal, but there's many different ways that our partners approach that kind of application. Gripping is another great example. I mean, tons and tons of different gripping options, and it's all about how people are looking at what's the best way to get a hold of something. Um, I think probably probably the most impressive thing for me in my role is to work with these partners who are looking at these really complex challenges, um, and trying to solve them in the most efficient way, or they're trying to solve them in a unique way that gets the job done in the best way. Uh, if I take, like, for example, material handling, um, there are so many different methods to approach picking up a box. Um, and it's amazing to me to watch these partners that I get to work with do that application. What kind of material do we make the end effector out of? What kind of gripping mechanism are we going to use? Suction? Are we going to use mechanical gripping? Should we use air, like pneumatics? Should we do hydraulics? Should we do electric actuation? All of these factors that play into something as sort of sort of simple to a human as picking a box up. Um, that's been the other. I don't know if we're going to get the chance to talk about this today, but that's been the other, I think, really interesting thing about my job is um, just realizing how complex what human beings do actually is. Human beings are incredible and how much we take our own motor skills for granted. When you actually look at trying to program that into a robot, it's really a challenge. And we sort of just take things like, pick this box up out of a bin for granted. Yeah, it's a really, really fun part of my job, getting to watch how people look at these sort of, to normal people, non-engineers, that sort of look at these applications like, oh, this is a simple thing. I'm going to move something, or I'm going to weld something. I'm going to put something together,
Yeah, even just the statement, just make the robot pick up the box. To us, that's such an easy statement. And
Yeah.
to anybody, they look at it, they evaluate all the parameters, they see the size of the box, they see what it's made out of, they guess how heavy it probably is. And so all these judgments are made in fractions of seconds. And yet when you shift to the world of robot or computer programming, every single one of those details has to be so spelled out and so specific. Yeah, definitely. I give it the label of art and creativity, just in having, in my own background, having done some of these kind of projects where you can't take it for granted. What people do is certainly creative all the time, no matter how repetitive it gets.
I agree. Absolutely.
Now, knowing that you work for Universal Robots, that's kind of one of the pioneers in this collaborative robot field, which really it's more about the collaborative situations. It's really looking at those kind of situations where the robot may be able to perform the same tasks that an industrial robot would be able to, but the situation calls for the ability for the robot to work alongside somebody and therefore have integrated and built-in safety features. But what are some of the unique sets of challenges that you see that come from these situations that you've worked in? You've worked with hundreds of customers now with that are looking at collaborative robots for situations. And I'm just wondering what kind of challenges are there for those that work with maybe not just general automation and maybe not even industrial robots, but are specific to the collaborative robotic industry.
Yeah. So in collaborative robots, or cobots, right, is the moniker we use. I'm trying to think back through all of the customers that I've worked with. Probably the two biggest considerations that we take into with cobots. Obviously, safety is part of that, but every application we look at safety. Honestly, whether it's industrial robot or a cobot, you're starting from the same place and using a set of guidelines to try to figure out what kind of safety considerations do I need to wrap into this application. But I think what's unique to a collaborative robot application is almost always there is a need for dramatic flexibility. It's hard to paint a broad strokes brush and say every single application is going to have that need. But an overwhelming, I would say in my own experience, majority of applications I've worked with, they call for flexibility in the tech. And what that means is a robot could be deployed to material handling for one application, or for a day or a month or a week or something. And then it needs to be reprogrammed, potentially retooled, and taught to do dispensing, right, in the same facility. Even moving between types of material handling, so like inner diameter gripping versus outer diameter gripping, loading into a mill versus loading into a lathe. These are different. They look similar, but they're very different applications. Oftentimes they require different tools or different considerations. There's a need for flexibility with collaborative robots. That's usually one of the first things that I see customers start to explore, like how maybe I can use a cobot to do this. Typically, the other thing that I see is shared space. So a need for tech to go where people are going to be. In traditional industrial robotics, typically what you're doing is you're guarding the space so that people can't enter while the robot's working. At Frito, we use robots that were this way, where you have a fence that's put up around the actual operating area of the robot arm. There's a lockout tagout procedure so that before you can even get into the arm, there's no power, there's no air, there's no way that arm can hurt anybody. But with a cobot, maybe it ties into flexibility, I guess, as well as I'm thinking about it. But there's a need for a person to be present. So either there's a very dexterous task that the robot is assisting with. So like maybe a good example would be the robot's doing some sort of material handling, and then a human is working there next to the piece of tech. doing some sort of very dexterous fastening task or something, or applying some sort of equipment to a piece that the robot just couldn't do. There are some things that are difficult for robot arms. Like a good example where I see people and robots work together really closely is in bagging, where the robot's doing some sort of material handling, and then a person is loading it into a bag or something, or there's some sort of bagging operation. Imagine trying to fasten something and bag it with one hand. It's difficult. So it's difficult for a robot too. But yeah, those two factors I see almost in every cobot application, where there's a need for a shared space and there's some sort of need for flexibility, usually pretty dramatic flexibility.
And that shared space, that kind of, to me, whenever I hear the term cobot, which means collaborative robot, I've always thought, well, collaboration means the working together of a team or a group. And in this case, the collaboration really is just between the people and the robots, which the whole intent of this was those situations where that flexibility calls for people and robot to be working in close proximity with each other.
Yes. Yeah. It's, I heard this was a quote from one of our case studies where an owner of a business, the company is called Task Force Tips. They're out in Indiana. And these guys make fire hose nozzles. The owner of the company had said it's a paradigm shift when you deploy a cobot, because you have to think of the cobot more as a tool, and not as a replacement for an operator. It's something that an operator is going to be using to help enhance their own capability. And that sounds very simple, but put into practice, that's a dramatic shift of focus. That's a different mentality to approaching automation.
In the past couple of years that I've had the privilege of being able to walk around trade shows and seeing a lot of applications, and I guess perhaps in those cases, people are walking around the robots, so it lends itself very well to having these collaborative situations. But I see a lot of cases, like you mentioned, with palletizing, welding, things like that. But I have noticed a lot of companies that there seems to be about 3 different application areas that have particular challenges, and therefore lots of companies that have difficulty solving these challenges, but some really innovative solutions built around them. And those 3 areas would kind of loosely be into the vision integrated robotic solutions, and those that are non-contact. So that kind of differentiates it from actually picking and placing objects, and then more force guided applications. There's a lot of different case studies that you see of those, but each one has a lot of different variables that must be considered, that sometimes just the simple pick and place robot that moves from point to point isn't really faced with those challenges. So I'd like to spend a little bit of time here, if we can, just kind of focusing on those 3 areas of application. Probably a lot of people see those as being candidates for their own challenges for automation. But I imagine that even taking a close look at those could lend a lot of frustrations, like, oh, we could never really get this to work. So kind of focusing on that first one, vision.
Okay.
What would you say, how is machine vision technology, especially now with AI seems to be embedded with all kinds of machine vision, how is that changing the landscape for a lot of industries? And do you see certain industries that are really taking advantage of vision combined with robotics to yield some solutions in ways that you really see expanding now and growing into the future?
Yeah. That's a good, all these are really good questions, by the way. So a particular industry, in my own experience with collaborative robots, I would say nearly every industry could benefit, or nearly every application kind could benefit from implementation of a vision system. I think the first question, always the first question I ask when I talk to customers or partners is, why do we need a vision system, right? There are some, to your point, you mentioned this, right? There are some applications where you might think it's necessary and it's not. There are some really innovative tools that have been built into our own technology that allow you to do applications that look like you might need a vision system pretty quickly. So like a good example is we have a grid wizard, like a palletizing wizard. I'm putting air quotes here because basically what it allows you to do is set up a grid pattern with just a few points, right? And so if you wanted to tend a CNC machine and load from a grid of raw parts and then put into a grid of finished parts, that application might look like it needs a vision system, potentially it doesn't. Um, if you do, can you make some fixturing and put your blocks into a raw fixture and a finished fixture? There are applications though where, because of the geometry of the part, because of just the complexity of the material handling, you need something to be able to identify a particular orientation that part is laying in a bin or something. Or I mean, even if you've got parts sitting in a grid, maybe there's looseness to that grid, and you want to make sure I'm getting the part the same exact way every single time, right? And so a vision system can help confirm that for you. Um, I mean, some of the more popular applications where vision is deployed and it works really, really well are obviously inspection. Any kind of like the robot's doing some sort of application and then it's presenting a part or something in front of a vision system for a go, no go. Um, I worked with a ton of companies on implementing robots with that check step, right? Like, is the part that we just fastened in the right place? And if it is, great, let's move on. If it's not, we're rejecting or putting that part back in for rework. Another great application space where you mentioned AI is often used is in like the bin picking area, right? So 3D bin picking. Um, I just for my own sake, bin picking is sort of half of an application. I think so. I hear a lot of people talk about it like it's a full application. It's really just the staging part of an application. It's what really all it is getting the thing out and ready to go for the application. You'd never consider picking the raw part and just presenting it to a machine as the application. The application is getting it into the machine, having it do something, and then pulling it out and putting it away. So bin picking is really like the staging. But that's a really, really good use case for a vision system, and especially one embedded with AI. Oftentimes what you see in bin picking is some sort of part that you need to get a hold of, and it's really difficult to either fixture that part, or there's just a million of those parts and it makes no sense to build fixtures. You want to be able to have an operator really easily load raw parts in front of a robot arm. There's a lot of different considerations as to why you might use a bin picking system, but that can be a really useful way to deploy a robot with an advanced vision system.
Yeah, prior to this job, I worked with 2D vision with a lot of robots, and I know that the quality control, the QC kind of inspecting final products was one of the big uses of that one. But here over the past couple of years, especially with that explosion in AI, and really that's just the computational ability to evaluate changing variables and changing principles. At the past few trade shows, just seen some really amazing applications of being able to with a incredible degree of accuracy, be able to repeat that motion over and over without having to go to the extra step of, like you said, arranging the part or presenting the part to the robot consistently every single time.
Yeah. And I mean, there's amazing things people are thinking about, and it related to like having the robot see, basically giving the robot eyes. I'm going to use vision really loosely because some of the vision stuff we have in UR Plus is not exactly vision per se. It's not a camera. You look at, like, for example, laser line profilers, where you're using a laser line to determine, what a part looks like or inspect something. We've got some really interesting partners that approach safety with radar, right? I've got a partner that's doing some really interesting stuff with radar. And so it's not per se a vision system because it's not actually looking. It's using it doesn't have a camera. Right. I have one partner that's based in the Boston area, the greater Boston area, that does radio frequency. They use actual radio waves to map points for the robot to then do applications against. Right. Actually, it's cool. It allows the robot to be based on a mobile platform and do really precise, repeatable applications. Even if there's partitions in the way, if there's haze or fog or smoke or something, because there's not a camera. It's tracking radio waves. So there's to your point, you mentioned creativity. Some really creative stuff people are doing.
Yeah, I think sometimes engineers get the reputation of following instructions and doing exactly the same thing. And there's the art people, and then there's the engineers. But from everything that you're describing so far, boy, engineering mindset has a lot of creativity involved with it too.
It really does. Yeah. Yes, it does.
Keynote speakers and live sessions for Control Automation Day are brought to you by Mouser Electronics. As your design fulfillment distributor, Mouser is your authorized source for millions of components from over 1,200 leading brands. Come discover, design, and develop with us. So if you were and probably have worked with companies who are investigating vision solutions to some of their challenges. And certainly the bin picking sounds like some where that 3D vision might be a great application, but are there some of them where maybe the application really is going to present some pretty big obstacles to using vision? Sometimes I know that the solution is simplify rather than make it more complex, but sometimes you really need more complex. Just if it's too simple, it just can't get the data that's required. But are there some obstacles that you know from experience that you might caution customers against? This could work for you, but you got to be careful of X, Y, and Z.
Yeah. So with vision in particular, one of the considerations actually always is the environment, right? Like, where is the robot actually physically going to be working? Where's that vision system going to be physically deployed? This is a funny thing. When I worked for Frito-Lay, we work with a lot of cardboard, right? All the chips go into cardboard boxes, and cardboard generates a lot of dust. Like when you fold cardboard, when you move cardboard, when you Frito reuses many of its cardboard totes, its boxes, as a way to help recycle and continue the efficiency, right? And so when you use used cardboard, it generates even more dust. Dust is a problem for a vision system, right? Any sort of particulate that's going to block the lens is a problem for a vision system. And so it's funny, I remember frequently many evenings of being up on a crane or up in a scissor lift, cleaning off photo eyes, right? Like cleaning dust, cardboard particulate off photo eyes so that our conveyors worked properly. If you're talking about like vision in, it's not every application, but I'm talking in generals here, but if you're talking like vision in like welding, say, splatter is something you have to consider, right? What is the weld actually going to kick off as you perform the task, right? Is a vision system going to get blocked by that kind of thing? In many machine shops that I've been present in, there's atomized coolant, right? So there's like the actual coolant that is spraying inside the machine to make sure that the tools don't overheat or damage the parts. That coolant becomes atomized and floats in the air, and it collects on everything. So, on a vision system, you're going to get maybe some blockage, or, another potential one is like, if for some reason, like you have like a screen or something, or if there's the robot's operating somewhere and then it's moving something around a screen, and a vision system is going to be deployed, it might not be able to see through that partition. There's a variety of reasons. Usually, almost always, you can boil it down to like, what's the environment? Where's this thing actually going to be deployed in? Another consideration is just experience with vision. Your vision is difficult. If you don't have a ton of experience with it, it might not make sense to start with a really, really advanced system. And a lot of people want to go right to the most advanced thing they can get their hands on. Maybe it makes sense to begin with a inspection, a 2D inspection before you get your hands into 3D bin picking. Maybe it's more efficient to build an array your parts and then pick out of a grid as opposed to pick out of a bin. A bin may look easier, but operationally, it may be simpler to just set up an array. There's a lot of factors to consider.
Which again kind of goes back to that creativity. It's not just a right and wrong thing to do, but there's a lot of variety that we have.
Yeah.
And you mentioned dust floating around, and that kind of reminds me that I work in a lot of lumber mill applications here down. I live in Southwest Washington State, so there's a lot of lumber mill applications, and getting dust on photo eyes, although they don't necessarily use robotics very often, but dust on photo eyes is a huge problem that's reoccurring. So it's very interesting to think about those kind of things. So moving on to the next application, the non-contact application. So again, that's differentiated from the ones where a robot gripper is actually picking up an object, where now we've got a payload. But in some cases, the payload is not changing. We might have things like a weld gun, where the weld is not actually touching the part, or adhesive glue applications. When those those kind of applications that they must follow a path. You're still programming a robot to do a certain operation, but you're not actually touching the part. Are there any sort of particular challenges that those ones, to me, it seems, just kind of looking from the outside, that it actually might be a lot easier than most applications. But yet at the same time, I do see companies spending a long time developing the solutions for these non-contact applications. So there must be some unique challenges that present themselves to these industries.
Yeah. So for non-contacts, the three, I mean, there's more than this, of course, but the three that jump to mind immediately to me are, you mentioned two, dispensing and welding, and then I would say painting, like some sort of like spraying, or, or like powder coat, that kind of thing. All three of those we've seen. And to your point, they can look simple because you're not manipulating a part. You're not, you know what I mean? You're not gripping something. You're not swinging a payload, or a dynamic payload where you're picking something up and putting something down. But the particular challenge in those applications that I've seen all revolves around how you actually move the robot. Like the actual pathing of the robot is so critical, right? If engineering is an art form, then robotic welding is an art form. I mean, it's so it's incredible to me. I'm not a welder, so I look in at this sort of with my nose pressed up against the glass, watching these guys do what they're doing. It's incredible to me, the consideration that goes into the fine motions of the robot arm. If you look at how a welder uses a torch, every welder does it a little bit differently. They've got their own style they approach their welds with. TIG welding is very different than MIG welding. Spot welding is totally different. They all require different techniques to move the torch, to move the tip, to actually get the seam that they're wanting. All of that needs to be factored into the robot arms. And typically when we look at, I would call these like process style applications. Our own internal company's nomenclature is just, how do you actually move the robot, right? There's a lot of consideration in just moving the arm. And so the factors that you're looking at are, can I get even tighter control out of the robot arm? How do I control can I do each individual joint, not just their speeds, but their accelerations? Can I look at, how can I look at manipulating multiple tool center points, right? So like TIG welding, for example, I'm moving an inert at the same time that I've got my torch. They're at a different area. So how do I control the angles that those are related to the robot arm? A factor that we see a lot in, it's just an environmental factor we see a lot in these applications, is how do we protect the robot against what's coming out of the dispense, right? So whether it's sort of whether it's a glue, or like in welding, there's the spatter. We have to make sure that the environment is suitable for the robot arm. Spray painting and powder coating are great examples as well, where typically the environment could be explosive, right? You could have a material that could be explosive. So how do you make sure that the robot is deployed in a safe way? Do you have to put a sleeve over the robot? Do we have to isolate the environment of the robot? There are some applications that require really fine, precise control from the tool. So, how do we get the arm, as it moves, to be speaking quickly to the tool to make sure that we're not over dispensing or under dispensing, or usually there's just a lot of fine tuning is what it looks like. We're taking the gross stuff that the arm can do, the gross big measurements, the big movements, and we're really fine tuning and honing that in to get a very, very precise either weld seam, or a dispense bead, or a pattern for spray. It's a far more complex application than I think a lot of people give it credit for.
And I can absolutely understand that when you mentioned having a lot of respect for welders, for people who understand the actual technology, let alone the robot itself. I definitely second that. It's there's so many different ways to do a good and a bad job at
Yes.
all of these kind of applications, and there's so much more to it. And in particular, the one that stands out to me is having done some robot programming in the past, like for instance, loading a CNC machine. You've got an approach point and then a pick point, and then maybe a couple of intermediate points, and then you have your approach to the place point, and then it sticks it in the jaw, and then it repeats the same path on the way back out. And a dozen points for a program, and certainly cycle time is important. But for these ones, do you find that there's a major mindset shift, or can somebody who's done a lot of these programs, loading, tending CNC machines or box picking, where it's again very, very linear and point based, to now shifting to this mindset of the motion path, hundreds or thousands of points must be met? Is there a mindset shift, or can you just hand the teach pendant to somebody between those kind of operations and they are perfectly adapted to just switching from one to the other? I kind of, in my own mind, I kind of imagine there being quite a bit of a mindset shift there.
Yeah. So this is where I think I'll get to maybe toot my own horn, or sort of like prop up the UR Plus section of our business. We've got some partners that have done some frankly amazing things, really astounding things with the tech, that have brought it to a point where you can nearly pass the pendant. By itself, as a blank robot, I would say that would be tremendously difficult for a user to go from that CNC style application, to instantly retooling and going over to a welding job or something. We've got some partners that have pre-built in a lot of the difficult functions of like a process application, to give users the capability now to where if they wanted to switch, they could do that really quickly. And what they've done is, so you mentioned, for example, if you're doing like a really complex shape or a curve or something, they've taken all of the complex motion that needs to go into that application, and they boiled it into like, teach these 3 points. They've taken, years and years of welding, actual real welding experience and robotic experience, and combine that into a really simple user interface to allow, operate. And there's dozens of companies that we work with that do this kind of thing, across various different power suppliers, all different kinds of manufacturers, that allow users to be able to say very, very quickly, put their robot in front of a welding application and say, all right, with these 10 points, I can weld my entire piece.
Since again, my background is mostly limited to the pick and place, I can tell you you're really wanting to make me hijack a robot at the next trade show and say, hey, can you teach me how to do that? Can you teach me how to use one of those tools that can convert from this point to point interface, which I'm more familiar with, to this path interface? Because it sounds fascinating to me. It's getting me pretty excited about this. Very interesting. Now, kind of moving on to our last application, which we're boiling this down to possibly 3 different applications, which there are far more than just 3 categories of applications available for robots, obviously. But this last one that really stands out to me as I see some of the more challenging applications is the force-sensitive applications. And I was kind of first introduced to this when I first learned about these compliance type devices, where in one or more axes, the robot is able to compensate for changes where normally if you started pushing on a robot or it runs into an obstacle, then that's going to create a fault. But in some applications, I kind of think of like deburring, grinding, those kind of applications where you're expecting to see some inconsistencies in a surface that might lead to what would otherwise be a fault. Maybe some of these now are a little bit more obvious than others, but what kind of challenges now are those kind of robot programs facing, and those types of end tools and devices facing, that some of the ones that we've talked about, non-contact, it's never going to run into anything. Box picking, it's probably going to be consistent enough that we're not going to run into an obstacle unless something goes wrong. But these ones, we're expecting collisions in one or more axes. And that sounds like there's a bunch of additional challenges built into that kind of thing.
So you're right. So it was funny, actually. So I've been with UR for 6 years. This is my 7th year. This year for me was really the first that I've become really exposed to all of the complexities of applications like you've described. So I would say deburring, grinding, finishing, sanding, polishing, that kind of thing. Anything where the robot is making contact with a part, and to your point, you're applying some sort of force or controlled motion on the part. Those are enormously challenging applications, and we've got solutions, but they're far more complex than I think most people give them credit for. So this year, actually, it was funny. I went to the A3 Association for Advancing Automation Robotic Grinding and Finishing Conference that was held in Minneapolis, and just became more exposed to how challenging this application is. And there's two things in addition to all the considerations we've been talking about. Right, we've talked about environment, we've talked about safety, we've talked about all these things you have to consider anyway when you're deploying a cobot. On top of that, you also now, with grinding, finishing, sanding, that kind of application, are looking at force control and compliance control. And so force control is pretty straightforward, right? How much force is the robot going to apply to the part that we're doing the work on? So if we're sanding, how hard do we need to press? What direction do we need to press? Do we need to be forgiving in certain axes, right? Or do we only want to press in the Z force? Or do we need to also, like if we're sanding, like say a rail, maybe we need to press down and against a rail to make sure that we're in the right location. That's all force control. Compliance is, there's going to be imperfect. If you're doing, I'm using sanding or weld grinding as an example. In weld grinding, we know that we're going to be pressing into an irregular surface because our goal is to try to shave that irregularity down into a nice smooth surface. If you just sort of try to muscle your way in there with a robot, you're going to do one of two things. Either you'll damage your robot arm or you'll damage your part. Either way, it's not an optimal solution. So you need like a springiness, a compliance on top of the force control, so that the arm can press, but you don't over press into a fault, and you don't damage your part, right? So if you're talking about sanding, you don't punch through the wood you're sanding through or something, or cause a scar on the material. So force control, compliance control, those two factors are, when combined, it's really a challenging thing to get your head wrapped around. We're fortunate in UR Plus and at Universal Robots because we've got some partners who've spent years studying this, years getting really good at this kind of control, and navigating like how much compliance do we need? Do we need active compliance or do we need passive compliance? What kind of force control do we need? Do we need, it's like the Universal Robot arms have a embedded force torque sensor in their wrist joint, and that's great. But do we need additional force control? Do we need to put like an additional force torque sensor on because we're doing really, really fine finishing, where we don't want a ton of force? So those two factors make that application really challenging. And then on top of that, you can get into all sorts of complexities about, again, how do you actually move the robot arm? I became exposed in, say, like in sanding, for example, if you not always, but if you use a sort of robotic approach and you just teach points and then have sort of a path that follows between multiple points, you can sometimes get a pattern that emerges on the part that you're sanding that the customers or users they're not looking for. They like the way that a human finishes, like the look of a human finished part. And so in addition to all this compliance and force control, now you also have to figure out, how can I move the arm like a human? Like, how do I achieve the randomness of a human? That's all. It's really fun. I'm not trying to talk anybody out of this. This is a really fun application to think about, but very, very complex.
You mentioned weld grinding, and while I might not have a lot of experience with welding, I can tell you I don't have a lot of experience with making good welds, but I do have plenty of good experience with grinding bad welds that I've made, and just kind of knowing that they're so irregular, and you press down on it, and like you're using a grinder, a flap grinder, something like that, and it's, you got to you look at the situation beforehand, and while approaching the part that you need to polish, you're already putting in those changing variables that you've received through your own vision, and you can kind of feel it beforehand in ways
Exactly.
that robots won't. And certainly, I guess in this case, there's even more hidden variables that a lot of these other robot applications won't need to take into consideration, because like with grinding a weld, if it's really bad, that part is going to start heating up and it's going to change its
Yes.
shape. It could potentially start warping if there's enough irregularity in it. And that's really something that no other robot application has to worry about. Certainly not
You're
the
right.
box picking or glue application. Do your partners, obviously they're going to compensate for those kind of things, and they're going to understand how to make sure that the heat transfer from the grinding tool to the part is minimized to ensure as successful a part as possible in the end.
Yes. Yeah. There are tons, I mean, there are dozens of factors that our partners are considering when they're helping customers deploy applications like this. But to your point, absolutely. You know, another consideration we didn't talk about, but one that's I think unique to this application is just managing the material, managing the actual finishing material. Um, you know, a consideration customers have a lot is cost saving. How do I actually save money doing this application? Automating is part of that, but also a benefit of automating is doing something repeatably, right? So I can, in addition to the actual savings I can get by deploying a piece of automation and doing a job over and over again the same exact way, can I potentially save material or cost on the grit material, right? So, a really big consideration in sanding in particular, where I'm using some sort of like, abrasive, is just how can I optimize my robotic motion so that I use every single part, every inch of that sanding material, that grit.
Yeah, so many variables to consider there. And I guess the other that this is talking a lot about the part itself, but I guess as far as the conservation of cost, as far as
Mhm.
the energy that we're putting into the system, also kind of goes into the robot itself. Is that also something that UR through its controllers has the ability to monitor? Is especially for these force sensitive applications, when you're trying to apply a lot of torque to a motor, you're going to be consuming a lot more energy over time. Are there ways to be able to use this data that the robot is collecting to say, for the last 100 parts, we've consumed a lot more energy. Maybe we need to go back to upstream processes and figure out where we can start cutting down, even if the cost in electricity for the torque of the motors is small. Over time, that can really add up. So is
Yes.
optimization of processes kind of the other behind the scenes thing that customers can take advantage of for these kind of applications?
Yes. Yeah. So our tools are, I mean, I'm biased, right? I wear a UR shirt. So our tools are designed in such a way that I think that they give users limitless potential to deploy our tech. Um, I actually had experience with this. I had a customer deploy some robots that were doing some sanding, and what they did was they sent to a CSV torque values, they sent force values, temperature values, um, basically every piece of or every reading they could get off the joints, they took it. They wanted to understand in real time what is our robot doing, and then look back over months and months and months of data and figure out, okay, well, how much, in particular, this customer was looking at time, right? Like the actual time to sand the part. Can we sand faster? And so they were looking at, well, to get a completed sand, it takes, X amount of time applying X amount of force with X amount of compliance. We see that there's some saving potential here. Over looking at months and months of data, we can see that we're able to actually do it faster. We're wasting time in this section. So they optimized their program and shaved, I think, nearly a second and a half, almost 2 seconds off their application, which it sounds like not a lot. But again, to your point, things stack up. If you're talking 2 seconds over the space of a year, 2 seconds every part for a year, that's a tremendous amount of savings. Um, so yes, all those tools exist, and we encourage customers, like, take advantage of what's on the robot. Really apply this thing to work for you, because it is a highly capable piece of equipment.
And certainly, I think any customers looking at automation would be able to realize, like you mentioned, a second and a half. But if the process itself takes hours to complete, then maybe that second and a half of time savings turns into several minutes of time savings. And so,
That's
depending on
correct.
the scale and length of the project, that time savings can be realized. Certainly. Now, in installing these robotic systems, are there certain things that from the very beginning that you recommend that companies do? Like we'll imagine ourselves in the scenario here, somebody who is looking at installing a robot to perform one of these applications, but it hasn't already done so. Are there some easy steps that they can take right at the beginning to ensure that things like this optimization, data collection, monitoring, to make sure that they're not just getting a solution right now, here, today, but their solution is going to keep getting better over the years? Because that's really what we want with automation, is not just one solution that's inflexible. The whole point of cobots is flexibility and change and making it better instead of being locked into a situation. Are there maybe one or two key takeaways that you can think of, to words of advice for those?
Yes. So the first big one is embrace the paradigm shift with cobots, because they are a different kind of piece of tech. When you think about deploying a traditional industrial robot, typically what people are thinking is, I have an application that I'm going to set this thing up, press go, and let it do its thing. Right? I'm not going to. Maybe you're interacting with it in the sense that I'm checking in on it, making sure everything is running, but it's up and going. A cobot can be a really, really different story, and so I'm not in the sales role now. I do more design. I'm behind the scenes. I'm working with our partners, but when I talk to customers, I encourage them. This is a piece of tech that, if you think about this differently, you'll unlock so much more of its own capability. Can it do very similar styles to the traditional industrials? Of course it can. Absolutely. It's a 30 or 50 micron repeatable robot, right? So you're talking industrial grade repeatability. It's totally a capable device. But do you want to unlock all of the potential that the cobot can bring? That's going to involve a paradigm shift. You're going to have to think about this a little bit differently, just because it is a different piece of tech. That's the first part, and then the second part is, don't always be afraid to take the worn path. Right? There are partners who have spent hours and hours and hours, years, figuring out the best approaches to material handling, the best approaches to welding, to palletizing. Just because you can figure it out doesn't mean you have to, right? There are partners that have done this kind of thing, and they've optimized the use of our tech so that it can be really easily deployed. And so I encourage partners as well, take advantage of the ecosystem. There's a huge number of partners that have trod this ground. They've done the hard work. They've cut their teeth on some really annoying problems, and they've figured out how to get past those issues. So take advantage of their expertise, and utilize the stuff that they've put together, because it is really good.
Well, thank you, Mike. This conversation has been great. And like I said, if nothing else, it makes me really want to go explore some of the more intricate applications of collaborative robots and just dive down more into it. Now, I do want to finish here with one more fun, lighthearted question for you. I'm just curious, what was your very first actual robotic project, school or work related? And what was that project?
Oh man, robotic. I would use really loose term for robotics. When I was a kid, this is like a really old school toy. I guess I got an erector set. If you I remember the old like erector sets. I have grandparents that live in the East Coast, and they always encouraged me to get out and play with stuff. And so I had Legos as a kid, but Legos were, for at the time anyway, a different story than like an erector set. Erector set had like motors, and it could move. And I always think of I don't know if you remember the movie The Sandlot, where they built the big crane with the erector set. I always wanted to do that kind of thing. I was like, I want to build a machine that works. And so I had I got a toy erector set and got to build a crane. And I thought that was like the coolest thing. Like the coolest thing ever. My very first application at UR was material handling on a piece of fabric. These fabric pieces were used to wrap cables that go in vehicles, right? So like a big in the automotive industry, it looks like a little sleeve, and then it's got buttons on either side of the sleeve, and you can roll that sleeve up, and then you tuck the cords inside, and it keeps the cords safe and under a protective cover. And the application was picking these parts up out of picking, blank sleeves up out of a grid, and then putting them under a snap press, basically inserting a snap and grommet, right, so that the fabric can roll over and clip together. And I remember being amazed at just that you could deploy a robot to do that kind of. This was before I knew very much about robots, and amazed at what a robot could do. And it has been incredible since then to see, just to your point, creativity. I think that's the thing that separates humans from robots, is just, I don't see robots deploying themselves this way. I see people deploying robots this way and using their creativity to solve really, really hard problems with pretty capable tools. That's what will forever separate human beings from technology.
Some great insight. And don't worry about whether it's Legos or erector sets being your very first robotic project. I think that's totally valid. Those are,
I feel like that
some
counts.
of the most creative solutions, with first learning nuts and bolts, and actually getting into this engineering world. So I'm totally in favor of those kind of things. Well, Mike, thank you so much for your time today. I really appreciate it. You shared a lot of really great insights, a lot of great experience, and I hope that those that are watching that are tackling or looking to tackle some of their next automation projects have gained a little bit of knowledge about some of the challenges that they may be facing, and some really useful ways to be able to approach the solutions to those challenges in the future.
Absolutely. Like I said, thank you so much for having me. This is obviously what I do for my career, but something I'm so passionate about. I really love this industry. That I didn't even know I would be in, to be honest. But I've really found a home here in robotics.
Well, thank you very much, Mike. And thank you once again to our audience for joining us today for this keynote, sponsored by Mouser Electronics. And our sincerest thanks to Universal Robots and to Mike DeGrace for sharing his time and experience with us. We hope that you will visit the vendor booths and watch the other keynotes and live sessions, all of which will still be available on demand after today, so that you can share the experience with anyone who may have been unable to join us live. And remember, the more sessions you register for today, the better your chances of winning one of our giveaways, becoming the lucky winner of our grand prize of your very own 4-axis robot arm. Thanks for joining us for this Control Automation Day 2024 presentation, and we'll look forward to seeing you again very soon.